Hello everyone, so today we're going to go over the Unit 2 review. We will begin with question number 1. So there is an investment of $40,000 at a rate of 6%, and we're looking for how long it takes for the investment to double. So that means our amount is going to be $80,000. The principal will be $40,000, and the interest rate is going to be 6%, so 0.06. Okay, so notice that the ratio A over P is simply going to be 2, and we'll be using that for a few different parts of this question, so we'll just leave it there for now. So first part, it says to estimate the doubling time. And to do that, we're going to use the rule of 72. Where we simply take 72 and divide by the annual interest rate, in this case 6%, and we get an estimate of how long the doubling time is. So this will be 12 years. If we were to instead use a formula to find this, we can use this formula to the right. That has been rearranged to allow us to solve for n. So in this case, we have n is equal to log 2, since a divided by p equals to 2, divided by log 1 plus 0.06. Okay. From there, we can use a calculator to work this out. There we go. So this would be log 2 divided by log 1 plus 0.06, and we get 11.89, so we can round it to just 11.9, which is very close to, once again, 12 years. Okay, so the next part asks how long would it take for the investment to double if the interest was simple interest instead. So the simple interest formula looks like this. We have A is equal to P times 1 plus R times T. Once again, we can divide both sides by P first. So we have A over P is equal to 1 plus RT. Just like in the previous part of the question, A over P is simply going to be equal to 2. So we have 2 is equal to 1 plus RT. We can then subtract 1 from both sides, and also substitute in the interest rate of 0.06. So we have 1 is equal to 0.06 times t. And then we can divide both sides by 0.06, the interest rate. And we'll get that t is approximately equal to 16.7, so that will be 17 years. And that's it. So in this first example, we went over how to use both the compound interest and simple interest formulas. Although for the compound interest, we actually use a rearranged form of it to find the doubling time in this case. Now we're going to move on to using the Tvm solver. to work out some of these answers. So we're looking to grow $12,000 in this second example to $50,000, and there are two possible investment options: 6% compounded semi-annually or 5.1% compounded quarterly. So that means in both cases we have something like this. The investment will be $12,000 in both cases. And the future value will be $50,000 in both cases. Okay. The interest rate are different, so 6% for the first part and 5.1% for the second part. Of course, there are no regular payments, so zeros here. And finally, if the interest is compounded semi-annually, then both the last two values will be 2. And here it is compounded quarterly, so both these values will be 4. Okay, so from there, we just need to find out what n is. And whichever one of the two answers has the smaller value of n, once they have the same unit, is the better option, because it will take less time. So let's go to the graphing calculator again. So once again, we can go to the Tvm Solver. Here we go. So 6%, negative $12,000, future value of $50,000, and then both of these will be 2's. Okay, so we have 48.2805. Okay. And since there are 2 periods per year, the measurements, the unit of time in this case is going to be half years. So we can round this up to 49 half years. And then the second part, we just need to change a few numbers on the graphing calculator. So this will be 5.1 instead. And the last two values will both now be 4. And n is going to be equal to 112.6427. And we can round this to be 113 quarters. So right now we are comparing half years to quarters. So in order to have a comparison that makes sense, we can simply multiply the 49 half years by 2, since there are 2 quarters every half year. And we'll get 98 quarters. And of course, 98 quarters is less than 113. So the better option will be the first one. And that's simply because it takes less time. Going to rewrite these so it's a little bit less squished. So here we have 113 quarters once again. Okay, let's look at the next example. So of course we can use the Tvm solver to find other values as well. So here we have a case where someone started investing at 5 years old, and now the person is 25 years old, so 20 years have passed, and it's a regular deposit of $5 every month, and the interest rate earned is 5.8%. So there are a few parts of the first question. A few parts to the question. The first part asks for how much did he invest altogether. The second part asks for the current value, and the last part of the question asks for the rate of return. So let's look at how much did he invest altogether. And this will be a simple multiplication in this case. $5 per month times 12 months per year. 12 months per year. And this was for 20 years. So when those are all multiplied together, we'll get $1,200 total investment. Okay, so second part asks for the current value. So this was 20 years of monthly payments, so that will be the period. The interest rate is 5.8% as stated in the question. There was no initial value in the investment. It was regular payments of $5. We're looking for the future value, and both the last two values will be 12 since the interest is compounded monthly and it is monthly savings. Okay, so let's look at now the graphing calculator once again. Starting from the first value, we have 20 times 12, so that's 240 months. 5.8% interest rate, 0 for the present value, -5 for the regular payment, and then both the last two values are 12s. Now we are looking for the future value, so we can solve for future value, and we get $2,256.24. Go ahead and write that down. So that's 22.56 So that's the second part. We found the current value. Okay, and then the third part of the question asks for the rate of return. So the rate of return is equal to earnings divided by investment. So in this case, we can simply subtract the future value of $2,256.24, and then we can subtract the initial investment, which is $1,200 in total, and then we can divide that by the $1,200 investment. And once we do that, and of course we're going to write our rate of return as a percentage, so go ahead and multiply by 100%. And using a calculator, we'll get 88.02% return. Okay, so that's one part. Now let's move on to the second part of this question. Still about the same person. So same future value as in part A. So that was once again $2,256.24. Now, instead of starting at age 5, Warren is now going to be investing starting at age 20. So instead of having 240 months, this will simply be 5 times 12, so 60 months time investment. So the assumption is that the interest rate is the same, so 5.8%. Still no present value, and these are both still 12s. And now we're looking for what will be the new monthly payments. So now we can go to the calculator, simply change the first value to 5 times 12, which again is 60. And then we can solve for the PMT, which is going to be $32.50. So instead of putting aside $5 a month in order to reach the same goal, Warren would now need to set aside $32.50 per month. Okay. Our last example is a portfolio question. So we're just going to be looking at the current value of Alex's portfolio in this case, and looking at the rate of return on that portfolio only, because both of the parts are very similar. So we're just going to work on one of the two portfolios. Okay. And quick overview of this portfolio, we can see that the first two parts are both lump sum investments, and the last part is a regular savings. Okay, so first part was a $5,000 GIC, so the PV is going to be negative 5,000. Purchased 9 years ago, earns 2.6% compounded annually, so 0 for PMT, and both the last two values will be 1, and we're looking for the future value. Okay, next one was a Canada Savings Bond, CSB, that was bought 4 years ago. Sorry about that. Interest rate is 3.1%. Present value is $2,000, so negative 2,000 there. No regular payments. Again, we're looking for the future value, and both the last two values will be 2 because it was compounded semi-annually. Of course, because of what we set P/Y to be, we also have to multiply n by 2 to make sure that those two units match up. Okay, the third part, it was 5 years weekly savings, so times 52. The interest rate was 1.4%. There's no present value. Regular saving was $15. Again, we're looking for the future value, and both P/Y and C/Y were 52. Okay, so now we can go ahead and use the graphing calculator to find all three of these. Okay, let's look at what we have. First part, n is equal to 9. Interest rate is 2.6%. Negative 5,000 is the present value. 0 for PMT. And then both the last two values were 1s. So the future value there will be $6,299.36. Let's go ahead and write that down. And then we have the second part of the portfolio, the bonds part. So that will be 4 times 2. Let's put away for 8 half years. Interest rate of 3.1%. Negative 2,000 was the present value, and both the last two values are 2's. Let's go ahead and solve for the future value. That's going to be $2,261.88. Okay, and finally the last part, the weekly savings component of the portfolio. It's going to be 5 times 12, so 260 weeks. 1.4% interest rate, 0 present value, negative 15 for the regular payments, and both the last two values are 52 for the number of weeks in the year. And the future value in this case is going to be $4,039.18. Okay, so the next part of the question is asking for the rate of return. So in order to calculate that, we need to find out how much was invested altogether. And in this case, that would be the GIC, that's $5,000. The savings bond, that was $2,000. And then 5 years of weekly savings of $15 each. Okay, so altogether, $10,900 were set aside. And of course, we have to find out the amount of money that the portfolio is worth right now. So that would be $6,299.36 for the first component. The second part, we have $2,261.88. And the third part was $4,039.18. So added together, we have 12,600 and 42 cents. Okay, so in order to find the rate of return, just like in our previous question, or one of the previous questions, that's going to be 12,600, so the total value of the portfolio, minus 10,900, which is the amount that was invested in the first place, and we'll divide this by 10,900, the investment total, and after that we're going to multiply by 100%, since we tend to report rate of return as a percentage, and we'll get 15.6%, rounded to the nearest tenth. Okay, so that's it. That's an overview of the unit, the different kinds of questions that are in there, both using the formulas and also using the Tvm solver. And that's it for today. So once again, thank you for listening.